Okay, so last week we got introduced to factoring, and we started out factoring when A was equal to 1, which made it pretty easy because our leading coefficient was 1, and so it was very basic. That was an intro. So now what we're doing is we are going to be stepping it up a little bit, and we are looking at factoring my ax squared plus bx plus c when a is greater than 1. Okay, so again, this is when a is greater than 1. So we got kind of the feel last week, and now we're going to dive in and we're going to look at a little bit more of a challenging problem. So let's say I have 4x squared plus 13x plus 3. What we are going to do here is we are going to use a table to help us factor this. So my table will consist of factors of 4, factors of 3, possible factorization, and then middle term. Okay, something like this. So when we take a look at, I don't know if that made it any clearer. When we take a look at factors of 4, that could be 1 times 4. That could be 4 times 1. That could be 2 times 2. Okay, factors of 4. Then we look at factors of 3. 1 times 3, 3 times 1, and 1 times 3 again. So technically, this one, I wrote it as 4 times 1, but we're probably going to want to leave this one, as 1 times 4, and this will make more sense in a minute why. Okay, so I have my factors written out here. Pretty basic and straightforward. So possible factorization. The factors of 4 are going to be what is going with my x, and then the factors of 3 are going to be my constants. So this would be like x plus 1 and 4x plus 3. So these two were my constants, and these two were my coefficients to x. So if you take a look at this, basically we are going to then determine what the middle term would be here. So this creates a 4x, and this creates a 3x, which is equal to 7x. Okay, 7x is not the middle term, so that one doesn't work. So now I'm going to look at my next one. This one is going to be x and 4x again, and then I'm going to have plus 3 plus 1. And when we do this, we end up with 12x plus x, which equals 13x. That one does create the correct middle term. Just for good measure, we're going to check out this bottom one though. These are my coefficients to x. So I have 2x times 2x. Oh, that needed to be a larger one. Plus 1 plus 3 as my constants. This ends up as 2x plus 6x, which is 8x, so that does not work. So now that we have this line here that created my middle term, so this one here gives me the correct information. I'm going to take that and I'm going to use here possible factorization as my answer. So x plus 3 times 4x plus 1. There we go. I'm done. I've solved it. Okay, and then we can always go back and check. Remember, checking is important. I know y'all don't like to do it, but it is. So if I FOIL this back, this is 4x squared plus 12x plus x plus 3, which makes 4x squared plus 13x plus 3. So yes, it works out to be the same. Okay, we're going to try another one together.
Miss Shaw,
Yes.
I just had a question.
Mm-hmm.
So, like, why do we factor out polynomials? Like, I just kind of confused. Like, what do we use it for after we factor it out?
Currently, nothing. However, we will be using it coming up. Okay, so right now, there's nothing we're using it for. There's nothing that we're getting from it, but we're getting to that next step in the next unit where we will use this. So this is kind of like a stepping stone to where we're going. Okay. Okay, here is my next example. So this one here is going to be 3x squared minus 7x plus 2. So again, we're taking this leading coefficient. So we're going to find the factors of 3. Leading coefficient factors. Factors of my constant. So factors of 2. These are possible factorizations. And then this is, does it make the middle term or not? Middle term. Okay. So this is like the standard table we can use anytime we have a bigger than 1. So factors of 3. So this would be like 1 times 3, 1 times 3. We'll just leave it at that. Okay, and then factors of 2. So one of the things I want you to notice in the last problem and this problem, when we did the factors of my leading coefficient, I put these in order from smallest to largest, right? 1 came first and then 3, and then I repeated it again. I didn't flippy flop these. Okay, just something to kind of keep an eye out for. So factors of 2. Now, this problem happens to be a little bit different than our last problem. And that difference is something that's important to pay attention to because it's signaling to us that we have something going on here. And that is, that pink kind of stands out, not really, but that's a negative there. Does everyone see that negative? So when we have that negative there, that means that we are going to have negatives somewhere in there. So they're going to have to add to be a negative, but multiply to be a positive, which means that the factors of 2 then have to be negatives because this here is a negative. So I have -1 times -2 or -2 times -1. Then we're going to take a look at the possible factorizations here. So remember, factors of 3 are going to be my coefficient to x. So I have x and I have 3x, and this would then be -1 and -2. So this creates a -3x, and this creates a -2x, and that there makes -5x, so that does not work because we need a -7. I ran out of room to put -5. Just saying, it got squishy. My apologies. Okay, so over here we have x minus 2, and then we have 3x minus 1. This becomes -6x plus -1x, so that is -7x. So that is going to be the factorization that works here. So my final answer is going to be x minus 2 times 3x minus 1. And then as I keep pointing out, I'm going to check it to make sure. So this becomes 3x squared minus 6x minus x plus 2. So 3x squared minus 7x plus 2. Yep, those match. So I know that I went ahead and solved it correctly. So one of the things I want you to kind of pick up on and notice is that this is obviously a lot of guess and check, like an educated guess and check. There is not like anything else going on here. So that is something to just kind of pay attention to and realize. Now, I'm going to show you another problem, and this problem is going to be a little bit different. This problem is 5x squared plus 15x plus 10. So when I look at this problem to begin with, the first thing that I notice is that they all the terms share a common factor. That common factor that all the terms share is 5. So I'm going to go ahead and I'm going to factor out that GCF in order to help to simplify my problem down. So 5x squared plus 3x plus 2. Now, when I factored out that 5, that GCF of 5, I now have a as 1, right? My x no longer has a coefficient larger than 1. So that means we can go back to basically what adds to be this and multiplies to be this. So adds to 3x, multiplies to 2. So factors of 2 would be 2 times 1, -2 times -1. I got nothing else. So then which one adds to be 3? Oh, I guess I didn't need my x there. Sorry. Adds to be 3. Well, this one would add to be a -3, and this one adds to be a +3. So there we have it, 2 and 1. So then I have 5 times x plus 2 times x plus 1. And that's my final answer. So if I'm looking at a problem and there is a GCF, then what I'm going to want to do is I'm going to want to pull out that GCF because it just makes my life so much easier and it simplifies the problem down. You all should realize, though, every problem we give you is not going to be nice and neat with a pretty bow on it where I can get A to be 1, right? So we have to know what to do if A is going to be greater than 1 and I can't factor out a GCF. Now, there is another way to go about doing this that I'm going to show you that I don't know, I personally like it a little bit. So that's what we're going to take a look at. This is one more strategy for today. I do have another strategy up my sleeve that I do not plan on introducing quite yet, but I will eventually. I very briefly talked about it the other day, but I am not going to go back to it at this moment. Okay, so what we have here is going to be, let's say, 2x squared plus 13x plus 15. So we can take a look at this. We can automatically determine that there is no GCF here. That's not going to work. So what we are going to do is we are going to look at this in order to basically factor by grouping. So this is my 2x squared. This is 15. What I'm going to do here is I'm going to take my 15 and multiply it by 2. So I'm going to take the leading coefficient and I'm going to multiply it with the constant. That creates 30. I am now going to do like my standard thing of what multiplies to 30 adds to 13. So this is multiply to 30, add to 13. Okay, that's what we're doing constantly. There's no getting around that. So 30 I know is 3 times 10. Add that, that makes 13. Okay, I don't need to make a zillion like silly guesses just to make guesses, right? If I can see it and I know it, then I can do it. I don't need to do a guess and check if I don't need it. So now what I'm going to do is I'm going to take this and I am going to take it here and I'm going to split this middle term. I'm splitting this middle term. This is 3x and now this is 10x. So when I look at this, I now have, oh, I should have written this the other way to make it nice and pretty. Can we write it the other way? Sorry, y'all. I didn't notice at first. 10, 3. Okay, my apologies. I believe that's what we want to do here. So now I'm going to have 2x squared plus 10x plus 3x plus 15. Now, there's a reason that I wanted to change my numbers to write it this way. And the reasoning is because I want to be able to pull out a GCF. Okay, because this is, again, factoring by grouping. Okay, so because I'm factoring by grouping, I want to pull out a GCF here in order to make it a little bit nicer. So that's why I rewrote this, right? Because if I had 10 listed second, or if I had 3 listed here, like I originally had, 2 and 3 don't share anything in common. Is everyone seeing that? So that does not help me. But when I rewrote it, 3 and 15 share something in common and 2 and 10 share something in common, right? So now that I have this and I split that middle term, I am going to take this here, this polynomial, and I am going to create 2 binomials. So here is binomial 1. Here is binomial 2. What I'm going to do is I'm going to pull out the GCF from each binomial. When I pull out this GCF, it's 2x. That leaves me with x plus 5. Everyone following still? We're feeling okay? Okay. Yeah.
There's still an x left over because of the squared, right? I just want to make sure that the
Yes, correct. Then here, my GCF is 3. So I'm pulling out a 3 and I'm left with x plus 5. Okay, when I factor by grouping, this and this has to be the same. Okay, if I get down and what's inside my parentheses is not the same, then either I did something wrong. Well, no, that's basically what it means. I did something wrong. So you need to go back and look. Now, what this is going to do is this is going to create my 2 binomials. My first binomial is going to be these coefficients. So that's 2x plus 3. My second binomial is going to be what is matching, and that is my x plus 5. So because these are the same thing, I'm writing it once, and I'm taking my coefficients and I'm creating a binomial with that. So then, as always, let's do a nice little check here to make sure this worked out and I didn't trick you all, because there's no telling, right? So first I have 2x squared, first outer, plus 10x plus 3x plus 15. That makes 2x squared plus 13x plus 15. That matches. Great. I factored it correctly. This here is my final answer. So as you can see, there are a number of different ways to go about doing this, right? One of the ways we did it is by, in example 3, factoring out, this is example 3 here. We factored out the GCF to begin with, and we got a to equal 1. Obviously, if that's a possibility, that is like the best thing to do. The second way we can go about factoring is we can make a table. Okay, our friend the table, right? This is a guess and check method. I got to keep working it until I get the right answer. Or my last way of doing it is to factor by grouping, which is basically like making the table, except it's a little bit more organized and directed, right? There's less guess and check needed. It's just math. So factor by grouping. These are the different ways we can take a look at factoring if we have a greater than 1. So now what I'm going to do is I'm going to have you do some do now problems. These are going to be like some classwork practice problems to just make sure we know how to do this stuff, because that's pretty important. And here we go. These are the problems that we are taking a look at today. So this is 4x squared minus 7x plus 3. 2x squared minus 5x minus 7. Negative 4x squared minus 8x plus 5. 14x squared plus 31x plus 15. 6x squared plus x minus 12. 24x squared plus 66x plus 42. Number 7 is 36x squared minus 103x minus 120. Number 8 is 8x squared minus 56x plus 48. So these 8 problems we are going to do, there will be a place to turn them in. And this is going to be our classwork practice to ensure that we know how to factor when A is greater than 1.